In this video, we're going to discuss two of the many alternative subtraction algorithms that exist. The two algorithms we're going to discuss are the Cashier's algorithm and subtracting by adding the complement. The Cashier's algorithm is based upon the missing add-in model of subtraction. And the missing add-in model states that A minus B equals C if B plus C equals A. In other words, if you want to know what is the difference, what's A minus B, all you need to do is you need to reframe that and say, what do I need to add to B, that's our C, in order to get to A? For the Cashier's algorithm, what cashiers do is they do this when they're returning change. Next time you go to a store and give the cashier some change, see how they're counting it back. So what the cashier does is, supposing you gave them 343 or bought something that was $62, and for some odd reason you gave them $343. What would your change be? The way that a cashier does that is they start counting back. They start adding on to 62. So they would start with 62. And because this is often done in the context of money, the amounts that are added back are essentially common money amounts. So if I take 62, I'm going to say, okay, I add $3, that would get me to 65. So I say 65 would be next, and that's when I add 3. That gets me to 65. Then I say, okay, I'm going to add a 5. I'm going to give you back a $5. So that would get me to 70. So plus 5 more. Now I'm at 70. I'm going to say go up to, I'll give you 20. So that'll get me to 90. So give it 20 back. Then another 10 gets me to 100. So they're counting back 62. They say 63, 64, 65, then 70, 90, 100. So that's plus $10. Now I'm going to start giving back hundreds. So we have 200. When I'm counting up, that's plus 100. 300 plus another 100. Then I need to get to 43, so plus 40. So we'd say 340 plus 2 20s. So plus 40. And lastly, 343. So I'm going to say 343. I'm going to add 3 more. So what I've added on to 62 to get to 343 is right there. I add 8 and 20, that's 28, and 30, that makes 38 for the top 4. 38 and 200s makes 238, plus 40 makes 278, and then plus 3 more gets me to 281. So what do you need to add to 62 to get to 343? You need to add 281. So 343 minus 62 is 281. The second algorithm that we're going to discuss is called subtracting by adding the complement. And adding the complement, first of all, is based on the top number. So we're going to be working in terms of essentially hundreds. The complement, we're going to find the complement of what we're subtracting, and the complement is, okay, if we're working in hundreds, what do we need to add to 62 to get to, in hundreds, 999, because we're in hundreds. So 999. So 62 plus what, W for what, equals 999. W is a complement. Now what's easy about that is you say, well, I need to get the 2 goes up to 9, so that would be 7. The 6 needs to go up to a 9. What do I need to add? That would be a 3, and I need to get a 9, so 937. So it's really easy to come up with a complement. You just say, what do I need to add to 62? So I need to add the 7 and the 3 and the 9. So the complement of 62 is 937, at least with respect to this problem. If the top number were thousands, then the complement would be 9,937. So what you do when you add the complement is, instead of doing the subtraction problem, which students tend to struggle more with, you add the complement. So instead of doing this problem, I'm going to do it over here. I'm going to say 343 plus the complement of 62, which is 937. Okay, let's add those up. So 3 plus 7 is 0. Add the 1. So we're adding. Students are more comfortable with adding 1 and 4 and 5. That gives me 8. 3 and 9 is 12, so 1280. All right, so when I add the complement of 62 to 343, I get 1280. Now, what you have to do to find the difference is you cross out the leading 1. There will always be a leading 1. And then you add 1 to the end. So you cross out that leading 1. You're leaving with 280. 280 plus 1 is 281. And that says that 343 minus 62 is 281. All right. Let's do this two more with maybe 2 more problems, same 2 algorithms, but with some more complex problems. Okay, so Cashier's algorithm for 4,021 minus 1,462. We kind of have to suspend belief again. I bought something for $1,462 and I give them $4,021 for some reason, but we're just going to say, well, I'm just counting up. That's the idea. So 1462, I need to count up. So I start with 1462. That's my starting point. And what do I need to add to that to get 4,021? Well, I would add some 1s. I'd say, okay, I'm going to add 1, which gets me to 1463. That's plus 1. Plus another 1, 1464. Plus another one is 1465. Now I'm on a 5. Remember, we're adding sort of common money increments. So now I add 5. So I've got 1470 when I give you $5 back. Okay, now I'm on a 10, so I'll give 10 and 20. I'll give back 30, so it gives me to 1,500. So that's plus 30. Now, okay, so now 1,500, I can give back 500. So that's 2,000 when I give back 500. And I can give back now 2,000, so plus 1,000 and plus another 1,000 gives me 4,000 when I give back 2,000. And lastly, give back 20. I want to get to 4,021. Remember, I'm trying to count up from 1462 to 4,021. So I'll give back a 20 in change, 4,020. So that's plus 20. And lastly, I want one more dollar. So I'll say 4,021. As I'm handing you back these dollar bills, that's plus 1 more. So the difference is what we added to 1462. Let's figure out what that would be. That would be, let's see, 2,500 right here and here, plus 50. So that's 2,550 right between all those. Then I've got plus 1, 2, 3, 4, and 5 makes 9. So plus 9 more. And that would say my answer would be 2,559. So 2,559 when I count up from 1462 to get 4,021. Let's try adding the complement for the same problem. So we're dealing our top numbers in the thousands. So our complement, we'd need to get to 9,999. So you say, well, what is a complement? What do I need to add to 1462 to get to 9,999? Now, the easy thing about adding the complement is you can just say, okay, what do I add up there? What do I need to get from 2 to 9? I need to get a 7, right? From 2 to 9, I need to get a 7. From 6 to 9, for the tens, I need to get 3. From 4 to 9, I need to get 5. From 1 to 9, I need to get 8. Okay, so 8,537 is the complement of 1462 because 1462 plus 8,537 equals 9,999. So what I do is I turn this into an addition problem. So I take the original value, 4,021, add the complement of 1462, which we said was 8,537. And again, students are more comfortable with addition, so let's add those together. You get 7 and 1 makes 8. 2 and 3 makes 5. 0 and 5 makes another 5. 4 and 8 rather makes 12. So I have 12,558. Now to finish this off, you cross out that leading 1, and then add 1 at the end, and that gets you to 2,559, or that 4,021 minus 1,462 is 2,559 by adding the complement.